Hello, my fellow YouTubers. This is Roy back again. Tonight we are going to highlight the new coil. We'll dig into the coil and see what the difference is, and let's get a few peeps on, and I'll be back. Hello there. Well, thank you very much, Mr. Energy Transfers. We got a fascinating little highlighted thing to do tonight. Hey, Jason, how's it going? Hello, David. Give me a few minutes. We'll get a few more people on. Hey, Alex. Hello. I wound this new coil, and this time we went with numbers. Yeah, man, you're gonna like this, Jason. This is pretty good. So let me just start here. Back up a little bit. Before I get this turning, let me run in the house real quick. I will just show you that I readjusted the core so it sticks out a little bit now, and you can see how close the reveal is. The torque or the tension on this for that core with these big 1-inch cube square neodymiums number 52s is a lot there. So that's a lot of tension to overcome. But I started digging in deep, and I realized that if I wanted to go 3 times more of what my coil I had before was, this was based off somebody's on YouTube and how the winds and what coil size and all that. This time I calculated my own. This time we went with the numbers, and I got it all on paper here. And we're going to go ahead and go over the numbers, see how we built this. Also, you're going to be amazed on how fast it turns. Well, and look how tight this is. This is for real stuck there. And that's just the induction between that neodymium and that core. And that core is laminate. What's going on, Angel, in the house? Thank you very much, Angel, by the way, for posting my videos out there and in your part of the world and opening up more people to see my stuff. So I just want to say something first. I don't claim anything. I'm not ever saying I'm smarter than the average person. I'm self-taught, been doing it for 6 years now, and you know, I don't know everything. So I always feel that I have to ask more questions and learn more. So I just want to put that out there to everybody that on my videos, obviously I have a lot of videos. So as I started off looking back at my beginning videos, obviously I knew nothing. And even today I know nothing in a sense that I can look back at myself a week from now and say, damn, if I only knew this, if I only knew that. And you're always learning. And I think that's the goal that I always had with everybody. I wanted to show the people who knew what they were doing, that weren't doing anything, were just watching, that pretty much it's exciting, and then you don't have to be a trained electrical person or engineer or any of the things we cover in order to have some type of interest in stuff. So hopefully I can carry on. You look at my old videos and the progression of from now. If you get into my channel and you're new, start with the most recent and work your way back. You can see how I got there. I may have 5 years ago built a Tesla coil or worked on Ed's wheel, thinking I knew something, but in electromagnetic world, it's very hard to overcome the natural laws that we have in place on electromagnetism. And for you people out there who are looking to learn to try to build a generator or some type of different power source, and you're looking to, or you read about something that we call over unity, is 0 point energy that is above zero. It, to me, has always been a chase and a rabbit hole. But I would say this, that in the next few months of my journey, we're creeping into areas that I would say this, that here's a line, and from this line below is all men's knowledge. From this line and above is your special area where usually military or greats like Tesla or Edison or Heaviside or Faraday or Maxwell, James Maxwell, got to give shout out to him. Farmsworth, James Prentice, Leedskalnin. All these people were thinking out of the box, above the line. So one thing, why we're stuck in why you can't get more out than you put in is because when you deal with electromagnetism, you're dealing with stuff that's below the line. And that knowledge below the line, the laws that we have to abide by, is geared or challenged in ways that it's geared by electromagnetism, and it's challenged by trying to overcome that electromagnetism. So I just wanted to leave that out there. Let's go ahead and talk about this coil here. Well, this coil here is 23 gauge wire for a prime mover and 26 gauge wire for a tickler. I have 100 turns, and on the calculations for that, that would be this. This is what I was starting with, and I had to, because I have not enough spool height, that I had to knock it down. So I knocked it down to this bottom one. So we're putting 5.89 amps through this wire, which is giving us a lot more back EMF, I must say, and a lot more speed. I'm going to say 3 times the speed of what I had before. Before, I was only, in this coil, this was 1.37 amps. That's it, 1.37. I knew it was weak in the beginning, but I got the transistor to work, and I got it working. So very important stuff. Let me see here. Hello, Adam in the house. So we're pushing 5.89 amps. Let's go ahead and this thing is taunt. What I also did was down bottom here. What's going on, David? This here is a coil that I wound, and it's got many turns. I got an LED hooked up to it, and then I bent it. So the magnet is driving through it. So we're cutting the field lines along the front here, but we're also cutting it from the side because the side of this magnet is also pushing out. Now remember, this core here is pushing out of the North Pole, and the magnet is facing north out. All right, so let's go ahead. I have the battery on here so I don't burn out the transistor. We'll start off with the load on. And then what we'll do is we'll stop it, turn off the load, and let all the juice run through the transistor. And we're going to see a major difference here. Let's go ahead and put the positive on. Positive is on. And we are good to go. Let's give it a little turn. You can hear that. So now we have some serious chiming going on inside the coil. Now watch with speed. Speed has to do with everything. Now watch that light up down here with speed. Now let's go ahead and you can hear the difference, right? So we still can't overcome the lens effect right now. I want to show you guys something really cool. So right now we're kind of overcoming it just a little bit to keep it turning, but we're not going fast. That light's not lighting up. Now watch what happens when I go faster. It overcomes the inertia. Well, the inertia overcomes the magnetic field where it was hard to break from that core to that magnet. So right now you can see that we are issuing. What we got issues with here? There it goes. Now it's going to start picking up. The light's getting brighter. Listen to the speed, guys. Listen to that NASCAR. It's picking up speed. It's still picking up speed. It's still picking up speed. Now let's step it up. What I'm going to have to do is I'm going to unplug it because I can't. Now I'm going to take the load off of the battery, and I'm going to plug it back in. And it's taken off on its own. And now here's where NASCAR second gen engine comes in, to where this thing designed for the maximum output of the wire itself. A 23 gauge wire, its maximum current as a standing current, not pulsed, is 4.7 amps. Now at pulsed, I believe it was 7. So right now we're still in the warm spot. The coil's not even warm. The transistor's not. It's cold. Now let's go ahead and turn this thing up even faster. Now I'm going to put the load on while it's moving. I can put the load on, I just can't take it off. Picking up more speed with the load on it. Not to mention, so not only are we taking the back EMF and going into this coil or this battery and charging it, we're also picking up some some extra energy off of that coil right now. What's driving it? Well, this coil, Adam is driving it. I got my core on it. I got my 2N3055 is my switching device. And I got my little little pot right there, 1K. My resistor. Got my light, tells me what the heartbeat is of that transistor. And this 12 volt battery and this 12 volt battery. So we're putting 24 volts into this. Oh, I calculated this with 12 volts. So we're actually doubling the amperage. So these calculations here were based on 12 volts. So we're pushing about 11 and change amps. And I can use the pod and I can turn it down. And I can use that as a speed control. But she's running smooth right now. This is definitely second generation here. So, anybody have any questions, any comments? Here's the circuitry for what I have running. Here's the transistor 2N3055. There's that safety light, which is a neon light. It's an AC light. When that comes on, that means I have my it's my safety light. So when this backlight comes on, this one right here, is because I disconnected the battery. So the extra charge is not going out there, and that light will tell me that the battery's full or disconnected. And then you have your emitter, your base. So this is upside down. The pins are on the bottom side instead of the top, and your collector's the chassis. Resistor. I changed that resistor from 470 to 100. So it's 100 ohm resistor. 1K pod. That diode. Hey Kevin. And then you can see how I'm going into the battery coming off. The prime mover battery and the charger battery. In those resistors in recycled materials, the resistors, you can find them in circuitries and TVs. You can find them in radios. You can probably find maybe on the circuit board of a microwave oven. The transistors, yeah. Oh, the transistor, not the resistor. The transistor. Well, heck, over where you guys are from, you have a better transistor, which I don't have the number in front of me right now, but I'll post it up to you, Angel. And this 2N3055 was more on the eastern side. So on the western side over there, you guys had a one that was called a Tesla, I think. It's the same transistor, but it holds more voltage and it puts out more wattage. It's a stronger transistor. Where would you find these transistors in recycle? In radios. They were used for radios a lot. So I'd look inside your radios for that transistor. And you don't have to have that transistor, guys. You could try any transistor. So just go into your recycle stuff and pull out, use any transistor. Well, the way you can back off the heat is put some lights in. Like for instance, this light right here. This light here is in between in my trigger circuit part. So it comes out of the base, which is the switching side of the transistor, and then it goes into that light, and that light, we call it like the grain of wheat light. It's just a small 12-volt light bulb, and you can use that or a resistor. And see how I make it brighter now? And now the wheels start getting faster. Now wheels start picking up speed. But you can always use any kind of resistor. Light bulb, which I like light bulbs better, only because you can see what's going on. Easy circuit to build, guys. Once you get the wheel turning, it's up to your imagination. But all I'm going to say is in watch that when you start dealing with more coils, I don't care if you have a core or not, what you'll have is still electromagnetism coming out of this coil. And it does put a little, it does slow down a little bit. Not much, but a little. And as you put more coils and to put a load on that coil, it'll make a bigger magnetic field and it'll slow down the wheel. So that's why I say to get more out than what you put in, you literally have to get to where you're not looking to get more out electromagnetically. You got to forget about electromagnetically on trying to get it out. You have to go different avenues. Now everybody frowns on electrostatic, but I'll tell you what, the energy's not in the air. The energy's in the ground. Everything gets absorbed to the ground. Ground meaning the stuff you're standing on. No matter what it is, it's being absorbed to that. So that means the energy's there. But one thing we do know through our popular science is that the ground reacts to electrostatic. So that's where my next experiment phase will be going into, where we're putting on the Wimshurst plates on the side, and we'll have one plate passing another, and we'll be capturing that and creating a high pressure electrostatic plate. That electrostatic plate will be a 1 foot square plate. First, I'm going to drill a hole in the concrete. I'm going to put an 8 foot ground rod in. The ground rod is made out of steel plus coated with copper. It's a ground rod. That goes in first in the ground. On top of that ground rod, I'm going to go ahead and put a copper 1/4 inch thick 1 foot square plate right on the ground. Now, if you guys, I'm going to ask the question, what is 1 farad? Does anybody out there know what 1 farad of capacitance equates to? How much surface area is 1 farad? Anybody out there? Well, 1 farad is 1 square mile, 1 inch off the ground. Equates to 1 farad of capacitance. Now, with that being said, I'm going to divide that out down into 1 square. I'm going to put a plate down, which is going to be the core, the grounding rod, the plate, and then right above it, 1 inch above the ground, one inch above that 12-inch square plate, I'm putting another plate, which is going to be the plate where the back EMF of this machine is going to be converted and going up to electrostatic high frequency. That's why I'm messing with the machine with coils and trying to get the frequency up a little bit. I don't know exactly what the frequency I'm going to need, but I'm going to use high frequency, high voltage, and that's going to go into the top plate. Now what will happen is, just like a cloud, don't know how much I have to put in there to have the ground. So whatever the plate on the top is energized at, if it's energized a negative, let's just say, that means that the ground will put a positive. It's like a dipole expansion. The ground will put a positive on the ground plate. If I put a negative at top or a positive up top, the ground will put a negative. Well, normally the ground is negative as is. It only changes when electrostatic is above the ground and it's the opposite charge of what the ground normally is. So if the ground's normally negative predominantly, which it is, you would have put a negative in front of it, so the negative will repel each other, will push down on the top plate, will push down on the bottom plate, electrostatic, and therefore that whole grounding rod that's 8 feet down in the ground will radiate out the electrostatic, and it will therefore push away all the negative charge and allow positive to come to that plate. Now that's where I think how you're going to over unity, or how you're going to get more out than you put in. To me, tap it in that plate in the bottom and having it flip it on and off, just like the frequency here. So that's where I think using the Schumann resonance, 7.83 on up to 40 hertz, is what we need here, because if we're tapping the ground plate at the Schumann resonance, we just need to figure out when it needs to be tapped. At some point, the ground wave and the frequency from the wheel into the electrostatic plate should jibe at some point. I don't know how Ed figured out how to tap into that, but Ed definitely was not just using the wheel to make electromagnetism and electricity. This wasn't. He had plenty of batteries. He had plenty of engines laying around, hit and miss engines that he had laying around. The Army Corps engineers, they went and threw a bunch of hit and miss engines, a bunch of PMHs, a bunch of motor blocks that he had. They threw them all in the pit, and they covered the pit up. What's going on, my boy Tommy? This thing is kicking holy moly with the new coil. And listen, guys, just like Ed's wheel with his motor block, the core of this coil is incorporated through this core into this iron, into the core of that wheel. The spokes are iron, and so is the rim. Everything's iron. So just like Ed shows in the picture, he shows his wheel with all that iron. And what else does he show? How ironic is this? He also shows his bicycle. Not saying he did this, but how ironic he's showing his bicycle. And here I am with Ed's wheel over there, learning more about magnetism and how magnetism is stuck by the laws. It really is. If you're going to go against the magnetism with a coil or something like that, you're going to create the lens effect. And that's where it comes in and ruins everything. I mean, the minimal magnetism coming out of this coil and creating lens effect is the best I can do by having a coil with no core. Now I'm afraid to stick it in there with it running, so let's just get it to stop. This thing, I can't get my tachometer to be stationary, So I don't know. I'm gonna have to look online and kind of get a better tack. Watch how that thing, the magnet, sticks right to the core. There's some good induction right there. That's a lot of induction with these 1-inch cubes. A lot of induction. 1-inch cube number 52 neodymiums. They are insanely big. Look at these monsters. Insanely big. So let's go ahead and stick this back on. And there's not much lens effect with this. That's why I was pretty surprised. And you know, I was watching a video of some guys down in Central America, and they were building a windmill. And with all the Leedskalnin stuff I've been experimenting with and just watching other videos, you know, everybody's using a core. And you know, when you use the windmill, they want less resistance, so they don't use the core. They just use coils. No lens. No core. But there is some lens. Don't think there's no lens. Because, you know, the way I have it cupped around here and the way there's magnetism in there, if I were to put a bigger load on this, which is what we will try to do, not tonight, because I'll have to fasten this down. Once this becomes more magnetic, it'll want to attach itself to that magnet. But we will see the wheel slow down, but I need a tachometer so we can see it better. So let's go ahead and I'm going to take the battery off as well so it's not charging anything. Now watch the speed this thing picks up. Listen to this sucker. It's crazy. Listen to you can hear that thump and listen to that. Ah, shit. You guys can see me? I accidentally dropped the pot. The pot up there fell over and I pulled the wire off. You can hear that coil. It's just picking up speed, picking up. This whole thing's shaking because it's putting a big magnetic field out. So I turned the pot down. You can see the light went down, so I put less resistance. Well, this is more resistance. Then watch, I'll add less resistance. Listen to the wheel. And you can see the other light bulb is on. That is the light that tells me that my battery's unplugged. Now if I go ahead and start charging the battery again. All right, now you just heard that change its sound a little bit. And now that light went off because it's now charging that battery. And now I'm adding less resistance. And we'll start to see the wheel pick up speed. So it is a balancing act. Listen to that thing. That is crazy fast. I can't wait to get a tack so I can start putting more of a load on it. What's going on, Midnight Gardener? How you doing? So Angel, that was a great, You have a lot of people leaving comments, and I stayed on there for a while today, a long time. I thank everybody for their comments, and that's why I posted what I posted tonight. Yeah, Adam, I'll go to Harbor Freight and I'll get me a cheap tack. I got a couple, but it just... Why is it moving like it does? I got this thing. You think this would be okay? I got a little piece of foil on the rim. See the laser light, right? I know it ain't spinning no 233 times RPMs. This thing has got to be going at least 2,000 RPMs. At least. This thing is crazy fast. So this thing sucks. I'm aiming. I put a piece of foil on the wheel, I think. Let's stop the wheel. Let's see if we have, because I pulled the wheel off. I adjusted all this, changed the coil, put a new coil. Here's the old one, which only had a amp and 0.37. 1.37 amps going in it. Yeah, there's the foil. So that should be good enough, don't you think? That foil right there. All right, let's get it going again. At least I know the foil's there. I wasn't sure if I had the wrong side on. Clean it. All right, I cleaned it. It's picking up speed. You hear that thing? See, I think that 1600 was the right number. Yeah, I know. It's crazy how it sounds. Now I'm putting some damn amperage into it. So I'll start getting some volts, some meters on this sucker. Let's go a little faster. You see that red light? Yeah. Hear that going down? I just added a bunch of resistance to it. Now I'll speed it up. Watch. Listen to it. So now, lots of resistance. You can hear it slowing down. Now let's go ahead and turn it up. Less resistance. You'll see that light come on. All right, see the light? Now listen. Well, he did like sardines and he did like crackers. I guess some people don't understand that you have to have a good balance of alkalinity in your body. Since your stomach makes a lot of acid, that pretty much as your aging process starts, when your metabolism slows down, that metabolism is really in charge of making secretions in your alkalinity in your pancreas. To make secretions of alkalinity. So at that point, it's really up to you to put alkaline products in you. And basically, 80% of what we take in is acidic, what we eat, drink, and 20% is alkaline. And the only thing that's alkaline that we eat or drink is fruits and vegetables. Now, even if you eat acidic food such as grapefruit, pineapple, oranges, lemons, your body processes that. It's a fruit. So when it comes in, it's like acid, and you think it's like the acid in your stomach and it starts bothering you. Well, no, it gets you heartburn. Well, it's a different acid. When it's processed, it flips it 100%, 360 of what it, or 180 what it is, and it becomes alkalinity in your bloodstream, which all it really means is it puts more oxygen in your blood. The more oxygen that's in your blood, usually in your blood is 2 parts nitrogen and 1 part oxygen. And when you increase the alkalinity, you can bring it up to who's that, Adam? Basically, you need to get more oxygen in your bloodstream, which keep your cells healthy. Okay, I got you on Ed. And who knows? He could have got into some crazy ass energy to where it was like radiation to where it ate apart his stomach. Who frick knows? Like X-rays. Who wants that? You don't want X-rays on you. And Adam, you know that. Tommy, be a little positive. It's the process of everything. Now, whether or not we're helping it, that's another thing. I'm not talking about that. That's not good. All the plastic in the oceans is sad. All the waste that rural countries, they just throw all their stuff in the water supply, go downstream. Listen to this. Back in the day in America, everybody used to get rid of their trash by throwing it in the stream Why is that? Why did we think here that was okay back in the 1700s and late 1800s? We thought that was okay. Why? Taking your trash and putting it in the stream and letting it go downstream so it shows up on somebody else's property. What the heck? Adam, nice recipe on what? Oh, and Nick posted. So one thing I want to add to the live streaming, guys, this is I think is our next level, okay? Give me some comments on this statement. Everybody chime in. There's 10 of you watching. Everybody chime in. I want us to be able to have 2 people call in. I want to be able to engage with people verbally, meaning not through texting, which is good because the people can comment this way. But I also want to be able to talk. I want to be able to talk, open up a conversation, and have 3 of us as a 3-way. So we'll have people call in, and we'll have them on. I'll have questions. There's a lot of experts out there. There's a lot of people that know exactly what's going on. Myself, I would just say I know nothing, and I just bring the topics up, and we can learn through the process. Yes, an audio conversation, Angel. And that's, hey, Jason, and that's what I want to do, is I want to bring that to the next level here. So I want to get me a burner phone, and I guess I'll start off with a burner phone, and I'll post the phone number. And what we'll do is I'll send out my email. We'll have you guys email me based on a live show that's coming up. And we'll have to where we call you and I will talk email. I'll call you up. We'll you and I will already have conversation of whoever wants to be on the show talking wise. And what we'll do is I'll generate a topic or several topics, and everybody can chime in, as well as people can call in. And they can come in and get involved between you and me in conversation, along with the comments that are appearing up on the screen. And then a third party can call in and chime in. And then we could engage in different types of debates on different energies and different topics. I mean, this is wide open. One thing I want to say about Ed Leedskalnin, guys. One thing. Ed Leedskalnin may have never levitated a thing. Ed Leedskalnin may have not done much more than what he wrote, which I doubt. I'm not saying he did, but I'm just saying. The key is that Ed, why he's special in my life, is that he got me involved in this. This has been the best 7-year journey of learning and more about electromagnetism and the whole gamut, the universe, the solar systems, elements, things, and why this is even important to most people. They may have seen this once in their life. Ed, if anything, is Ed famous for is opening up all of our minds to what if. Now, if Ed never levitated with his wheel and he just knew how to use counterbalances and stuff like that, which I don't think that is what really happened. I'll put my 2 cents into here, but that doesn't mean it's right, guys. That just means It's my theory, it's my belief, and this is how I look at things. Ed opened my eyes to learn about all of this stuff I just mentioned, and he got me interested. That's my beautiful special gift that Ed had given me. And I'm sure that everybody else who ever heard about Ed Leedskalnin, Ed has given that to you as well, because he had got you interested. Now, whether or not the things we hear through the internet or whatever, floating stones, sound, floating rocks, moving rocks, getting them out of the ground, looking for the land, I want to believe all that. Whether or not it's true, you have your doubters out there. And you know what? I always believed that something good was going to come out of it. The fact that I learned about so many different things, and it took me 7 years now of filming on YouTube, that's why there's so many videos, I'm embarrassed to look at my old videos because I knew nothing. Nothing. But I started, and Ed intrigued me as he intrigues you guys. And for you guys to learn in your own workshops, or even if you guys are readers and you're not doing experiments, you're the people who help us experimenters get through a wall. We all come up against the wall. And that's the thing with electromagnetism. And that's what I mean by that line. Underneath my fingers is the line of electromagnetism world. And in that spectrum, the electromagnetic spectrum, there's laws that everything has to follow by. It's about the thinking mind above that line. And what I've done in 7 years is basically compiled the bottom half of the line, and then I've also dreamt about above the line. So I want you guys to be part of learning and a part of accepting that Ed handed the torch off. If he didn't do it, I know it could be done. It's so possible. That's why I keep talking about the ground. If you really are going to levitate, it's got to be the ground is got to be involved. The ground, if you want a stone or anything that's an element, it's got to be involved. And if you look at one thing on Ed's damn picture here, let me see which one. If you look at the one picture, I think it's in this one. No, here it is. If you look at this book, and if you look at this picture, this is what interested me, what got me going. He's got right here in this picture, he's got a chain that goes right here, and that's a pole. He's got a stake drilled into there, and he's got a stake coming out of the other end, and he's got this chain. It don't go to the stake and stop, which you would think, why are the stakes there? It goes down. Well, let's start from here. There's whatever that is a wooden box. There's cables that are not cables like chains that are holding this. They're the electric cables. They're coming down. And they come down here and go all the way around that side and goes to that pole and goes around that side to that pole. Then you have your chain, and in the video that Mike from Space put up, love Mike from Space. I wish he'd be on here chiming. The chain goes down here and then goes underneath the bottom and back up. So the chain is doing the hoisting, but he has poles in there. Now, I question the poles. To me, the electrostatics that I'm talking about here, you need something to attach to the ground or to the object to create the electrostatics. So what would happen if you have, leave your comments, if you have a boulder and you got a pole or a rod, iron rod, in 2 feet, and you got another iron rod in 2 feet, and then you have a foot in between them or 6 inches in between them. And if you were to pulse with the wheel or with something. I don't care what freaking wheel you use. But if you were to pulse it and put electrostatic, you would be able to move the molecules in the in the rock itself, the molecules, meaning you would be able, the domains in that coral would be moved because you have a rod in one end with a separation and another end with a separation. I don't think he drilled all the way through. That's my take, guys. That's what drove me to get the wheel, and I'm more interested in that part of it. I haven't even come close to being able to do that. I've been doing it for so long, I got people chime back in and say, hey, you're still at it. Well, you know what I'm still at? I'm still at the passion of learning. Whether it's this or I'm coming over here, which really tickles my fancy. All I gotta do here, these beautiful little guys. This is the electrostatics world. This is why I'm fascinated. All I gotta say is freaking NASCAR, guys. Did you hear the difference in speed? So that was me also using not voltage to change the speed. You had to hear that on that Tesla coil. I was adjusting the airflow going through the spark gap to gain speed. You heard that frequency. All of a sudden, you see those arcs coming out? NASCAR. So the fact that you could change the frequency on that Tesla coil top load by just introducing air to the spark gap and use it as a throttle. Leave your comments. What's going on, William? All right, Adam. Talk to you soon, buds. I'll let you know when we got the phone number going, and maybe you could be my first victim, all right? I'll bring up some good topics, and you're a very, very smart fellow. So, and what I like also, we'll have somebody else call in, and we'll start off with. Thank you. We'll start off with a couple topics, and we'll have somebody kick in that can chime in. So I'll talk to you later, Adam. All right, guys. Well, I had to calm that guy down. How do you think he likes the sparks in his eyeball? My minion here. Guess where I got him? Somebody threw him away in the trash. I couldn't leave him. I couldn't even drive by him. Imagine how bad it is for me to drive by a stray dog, or a cat, or a deer, or a bird, or a turtle. But he likes it right there. I had him over by Edge Wheel, and he didn't seem so happy. He likes this guy right here. He loves this Tesla coil. All right, guys.